Hi everyone, I'm Daniel Rawat. I welcome you all to my channel Cybersecurity with Daniel. This channel is dedicated to cybersecurity. Here we would explore the nexus of technology, business, and security in detail. I'm thrilled to share my knowledge with you in this cybersecurity adventure. I believe that cybersecurity isn't just about technology, it's about people, processes, and innovation. I have a background in business analysis, information security, web application architecture, and development, and I uniquely positioned to offer insight that bridge the gap between technical expertise and business strategy. Whether you're a developer looking to secure your web application, a business analyst seeking to understand the impact of cybersecurity on organizational objectives, or simply curious about the latest trends in information security, you have come to the right place. Join me as I explore a wide range of topics from threat intelligence and penetration testing to risk management and compliance. I will break down complex concepts into digestible insights, providing practical tips and strategies that you can apply in your own cybersecurity journey. So, if you're ready to unlock the secret of cybersecurity and embark on an exciting learning journey with me, don't forget to hit that subscribe button and turn on notification. I can't wait to explore the world of cybersecurity together. Thanks for tuning in, and until next time, stay secure. Hi everyone, this is Daniel Rawat, and today I'm going to talk about how to implement DevSecOps practices in cloud environment. Implementing DevSecOps practices in cloud environment can significantly enhance an organization's cybersecurity posture by integrating security into every phase of the development and deployment lifecycle. Let's dive into this in detail to understand the guideline for improving cybersecurity posture through cloud DevSecOps practices. First is culture and education. Foster a culture of security awareness and collaboration across development, operations, and security teams. Provide ongoing education and training on secure coding practices, cloud security best practices, and relevant compliance requirements. Next is automated security testing. Integrate automated security testing tools into the CI/CD pipeline to identify vulnerabilities early in the development process. Second is conduct static code analysis, dynamic application security testing, container security scanning, and infrastructure as code security scanning. To do that, there are a number of tools available in the market. First, you need to identify the security testing requirements, like it's a container security scanning, whether you want to do API security testing, whether you want to implement infrastructure as a code security scanning. So now let's understand about the static application security testing. Static application security testing we normally do using some popular tools like SonarQube. You can directly integrate with the Git framework and the source code, and whenever you're doing any build tool you're running, at that time SonarQube will be activated to identify any security vulnerabilities in your code, such as injection flows, insecure authentication, or any sensitive data exposure. So this is for analyzing your source code. Similarly, we can do dynamic application security testing. This is to test running applications for security vulnerabilities by sending malicious requests and analyzing responses. Third one is container security scanning. For container security scannings, we can use tools like OWASP JAMP, Burp Suite, and the Qualys web application scanning. And that can be integrated with the CI/CD pipeline for automated dynamic application security testing as well. At the same time, We can integrate container security scanning tools to analyze Docker images or Kubernetes configurations for security vulnerabilities and misconfigurations. So we can use some tools like Claire or Trivi or Anchor engine for automated container security scanning. Similarly, we can do API security testing. We can use API security testing for authentication, authorization, input validations, and the data exposure. Personally, I used Postman a lot, but there are OWASP API security project is also there, and API Fortress can be integrated into CI/CD pipeline for automated API security testing. Infrastructure as a code is security scanning. IAC security scanning tool to analyze infrastructure code like the Terraform and the CloudFormation for security best practices, compliance violation, and misconfiguration. Tools like Chekhov, DevSec, and AWS config can be integrated into CI/CD pipeline for automated IAC security scanning. We need to also understand, before establishing any security testing, we need to understand the policies and the threshold for defining acceptable level of risk and criteria for failing builds or deployment based on security findings. So configure security testing tools to enforce these policies and provide actionable insights for developers to remediate vulnerabilities. Automate test execution. Configure the CI/CD pipeline to automatically trigger security test upon code commits, pull requests, and deployment events. Ensure the security tests run in parallel and other tests to provide timely feedback to developers. We can do the integration with the test issue tracking and reporting with the Jira and GitHub issues, right? So integrate security testing tools with issues tracking system like Jira, GitHub issues to automatically create tickets for identified vulnerabilities, which can be further enhanced so that we can assign them directly to the respective developer. And continuous monitoring and feedback is very essential for this. Continuous monitor security test results and provide feedback to development teams to prioritize and address security vulnerabilities promptly. Next is immutable infrastructure. Embrace immutable infrastructure principle to ensure consistency and reduce security risks by rebuilding infrastructure from scratch for every deployment. Immutable infrastructure is a concept in cloud computing where infrastructure components such as servers and containers are treated as immutable, which means they cannot be changed after they are deployed. So instead of modifying existing infrastructure, changes are made by creating new, updated instances and replacing existing ones. This approach helps ensure consistency, reliability, and security by eliminating configuration drift and reducing the attack surface. Second is leverage containerization and serverless architecture to achieve immutable infrastructure. So this is an architectural thing, which is containerization and serverless architecture are two modern paradigm for deploying and managing applications in cloud environment. Both approaches offer benefits in terms of scalability, resource efficiency, and agility, but they have different characteristics and use cases. So containerization involves packaging an application and its dependencies into a container image, which can then be deployed and run consistently across different computing environments. So the key components for that is container engine, container image, container registry. It's a very, very high level, so I'll not emphasize more in the detail. But the benefits are portability, scalability, isolation, consistency, microservices. Use cases are application, modernization, continuous integration and continuous deployment, CI/CD, and hybrid and multi-cloud deployments. Whereas the serverless architecture is also known as function as a service, abstracts the underlying infrastructure from developer, allowing them to focus on writing code without managing servers or infrastructure resources. Key components will be small stateless unit of codes that perform a specific task or function in response to events or triggers. Event sources could be services or components that trigger the execution of functions such as HTTP requests, database changes, and message queues. Serverless platform, cloud service provider platform like AWS, Lambda, Azure functions, and the Google Cloud functions that manages the execution and scaling of functions. The benefits is it is it reduces the operational overhead. Serverless architecture eliminates the need for managing servers, operating systems, and infrastructure resources, reducing operational complexities. Auto scaling, serverless platform automatically scale the execution of functions based on incoming requests on or events, ensuring optimal resource utilization and cost efficiency. Pay per use billing, serverless platforms typically offer a pay per use billing model, whereas users are charged only for the compute resources consumed during function execution. Serverless architecture enable rapid development and deployment of applications by abstracting away infrastructure concerns and providing built-in integration with event sources and services. Stateless execution function in stateless architecture are stateless, enabling horizontal scaling and high availability without the need for session management or persistent connections. Use cases will be like event-driven applications. Serverless architecture are well suited for event-driven applications such as real-time data processing, IoT applications, and webhooks. Microservices orchestration. The serverless platform can be used to orchestrate and coordinate microservices based workflows where each function perform of specific task or action. Backend processing. Serverless function can be used for backend processing tasks such as image or video processing, data transformation, and file processing. Both containerization and serverless architecture offer unique advantages and use cases for deploying and managing application in cloud environment. Organizations can choose the approach that best align with their requirements, workload characteristics, and deployment practices. Additionally, hybrid approaches such as combining containers and serverless functions can also be explored to leverage the benefit of both paradigms. Now let's jump on to the configuration management. Implement configuration management practices to maintain consistency and enforce security configuration across cloud environments. Use infrastructure as code tools such as Terraform or AWS Cloud Formation to define and provision cloud sources. Implementing configuration management practices in cloud security for DevSecOps involves ensuring that cloud resources are provisioned, configured, and managed securely throughout their lifecycle. So suppose infrastructure as code, principles to define cloud infrastructure configurations declaratively using code. Use IAC tools such as Terraform, AWS Cloud Formation, or Azure Resource Manager templates to provision and manage cloud resources consistently and reproducibly. Store infrastructure code and configuration in version control repositories in the Git to track changes, collaborate with team members, and ensure auditability. Implement branching strategies and pull request workflows to review and approve changes before they are applied to the production environment. Develop security baseline templates that define secure configuration for cloud resources based on the industry and standards like the CIS benchmarks, organizations policies, and best practices. Integrate automated compliance checking into CI/CD pipeline for validated cloud configuration against security baseline templates. So use tools such as Chekhov, DevSec, or AWS config rules to scan infrastructure code and configuration for security vulnerabilities, misconfiguration, and compliance violation.